Hello, my name is Alessandro Tornicasa. I work for Dassault Systèmes as an industry process consultant, and I'm helping our customers and partners in the Euromed territory, which is what you see in the map, with our newest product development solutions. Today, we will talk about new product development tools that can be used from any device, and I will show you a real case of design of a winch. But let's start with introducing the topic of the new trends that will be driving the future of design. The first topic is the IT overhead. As you know, lots of softwares that we are using today, think about your CAD or your ERP, require an IT infrastructure that needs to be maintained, updated, and protected. We are hearing more and more customers that have been attacked by hackers, their data is stolen, and they require some ransom to get the data back. So companies need to invest a lot of money in security, backup, disaster recovery strategies. The next topic is mobility. So the software companies that have a good vision for the future from now until the next 10, 20 years well know that young people will guide the future trends and they are adapting to this. So today, many professional apps can work from a Chromebook or a tablet or a phone, and even your favorite CAD could work from mobile devices. Then let's talk about the data management. Recently, I was reading an article that said that young students that don't really use much personal computers, but they rather know the concept of devices and apps, but don't know the concept of folders because they are just saving into their device and they know that when they are launching the app, they simply click on the open command, then search for what they're looking for. Maybe they can filter, for example, filter a document, and then they will find their data. So in the future, all of us will interact with our data with an experience that looks a lot like search engines. And then we have the topic of collaboration. You know, lots of tools are gradually replacing emails. If I asked you how many of you are using WhatsApp or Telegram to communicate for work topics, many of you would say that you're doing that. And today, professional social networks are a very useful tool to follow up with our clients, partners, and collaborators in order to be always up to date on their projects or initiatives. Moreover, the pandemic has obliged us to learn how to use virtual meeting tools, and this enables us to communicate with anyone in any part of the world. Then we have the topic of more power, which means the topic of modeling. Today, designers want to have some powerful tools that will allow them to tackle much complex projects in a very quick way. And the technologies are there because we have new paradigms like artificial intelligence, cloud computing, or design assistant technologies, or even generative design that allows us to create impossible shapes. So how does Dassault System help us with this topic? Well, Dassault System has developed the 3D Experience platform, which is a cloud-based environment right into your browser that connects all the design project stakeholders, their ideas, the design data, and the solutions. And there is a plethora of tools for really every member of your team, not just design tools. So tools for project management, data and lifecycle management, 3D preview and markup tools, and built-in collaboration tools at every corner. But today we're talking about browser-based design. So browser-based design tools can work from any operating system because they work from a browser. So they will work from Linux or from Mac. And they don't require any install. So you simply need to launch your browser in order to use your app. And also they are being updated automatically, which means that the day after the update, you simply need to launch your design app and you'll find the new functionality and new features. Also, these tools have been developed with a native touch support. So the UI has been really conceived to allow you to really model and design for a tablet or even a phone. These tools also feature automated data management, so this will allow us to get traceability like revisioning designs, keeping track of history, or maybe restoring an old iteration and taking another pathway by creating, for example, a branch. There are new technologies, for example, like design guidance, which means that once you define your material, your loads, your constraints, and avoid areas, this tool will suggest you the shape of this component that will minimize weight. And there are also some computer-aided design technologies, and I'm underlining aided because in this case, for example, I need to assemble that washer, and the system will suggest me with the artificial intelligence what are the most likely locations where I would like to mount that washer, and it will automatically mount the washer for me. And these technology are learning from us, and they will improve as we are using them. So now let's see the first part of this project, which is the assembly of the winch you see in the picture. So we're going to use these innovative design tools to design this electric winch assembly. And today we will see Eric and Debbie, two designers that will collaborate on this. We will start with Eric. We will work on the assembly. So he's going to assemble the winch, and he's going to use bottom-up techniques and also top-down techniques. But let's start with the with the bottom-up techniques. So Eric is going to start his day in the browser. So he's going to use XDesign directly in the 3D Experience platform without installing anything. And now Eric needs to insert a couple of components in this assembly, which are a couple of gears. There are at least a couple of different ways to add components. So you can simply browse to your data, to the list of your components, and insert the component by drag and drop inside of the assembly. Or another option will be to simply search your component. You can use the precise name, or if you don't, you have filters on the left where you can filter by date or by meta properties. Then you can drag and drop the component in the assembly once you find it. Here we can see that the insert component command has some new tools like the ability to insert more than one instance of the component. In this case, we need only one gear, so we will leave the default value of 1. We can also toggle a more convenient view of the assembly with the view selector. And we will start creating mates. So we have all kind of mates that we can leverage like in any design tools, but we also have some advanced mates that in XDesign are called joints that will allow you to create gears, rack and pinions, pulleys. In this case, Eric will create a gear joint. So all you need to do is selecting the two gears, and in this case, we are defining the gear ratio. And then we're going to select the components to define all the mates that are needed to define this gear joint. In this case, we have a concentric mate, then we have a coincident mate to define the location of this gear. And then we also have an angle mate that will be used to basically drive the gear mate. You can also leverage some view filters, because in this case we want to hide the plane, so we will show the planes, because in this case this will be useful to define the angle mate that will actuate the joint rotation. So as you see, we are completing this gear joint that will connect the two gears, but also will connect the gear to the bracket. So we'll finish like before, selecting the references for the coincident mate and also for the concentric mate, and then we will select the mates to define the angle mate. And the gear joint is finished. And also we can test the motion by simply dragging and dropping by dragging the components to check the real motion. Xdesign also features some quick shortcuts like the V hotkey that will allow you to toggle the view filters. In this case, we're hiding the planes because are not needed anymore. The next step will be modeling a new component that will be the spool, and in this case we will use some top-down assembly technique. So let's summarize what we've seen. You can assemble your designs from anywhere and from any device. The user interface is very intuitive because it's been created by the same team that has created the excellent SOLIDWORKS user interface. And you also have some advanced mechanical made to simulate motion. So next will be showing how you can model mechanical parts. In this case, I mentioned that we are going to create the spool, and this will be done with an in-context technique. So we can call it a top-down assembly technique. So Eric will select the insert new component command. It will give the new name to the component. So he will call it spool. Then he wants this component to be exactly centered respect to those two brackets. So it will insert a few mates on the planes in order to make sure that the design intent will be respected. Also here, we have the ability to choose if we want to activate external references. By activating external references, you have the ability to create, let's say, adaptive components. So the spool will be able to update, for example, if the distance between the two brackets will change. So I will leave on the external references, and Eric will start a sketch. So he's going to create a rectangle. And as you see, it will create some references respect to the bracket existing geometry. In this case, the sketch will be completely defined. Then it will add some more geometry to create this spool. By pressing the S key, the shortcut bar will appear, and this will allow you to select some sketch commands, minimizing the mouse travel. So in this case, I'm going to choose the trim command to eliminate some geometry. As you see now, there is some blue geometry, which means it's not completely defined. So I will create some dimensions to define that geometry. So in this case, I'm putting a first dimension, and then as I put the second dimension, the geometry will become completely black, which means completely defined. Then I'm going to go to the Features tab, and I'm going to invoke the Extruded Boss command. So if I convert in a traditional CAD system, I would have to cancel the feature and recreate it from scratch, and maybe all the downstream features will fail. In this case, we have the concept of super features, which means that I can switch between an extrude, a revolve, or a sweep as desired, and the feature will switch, and also the downstream features won't lose references and will update. In this case, I'm going to change the feature to revolve, so all I need to do is selecting the revolve axis to define this revolve feature. Then I need to create some fillets, so I will select one edge, then the context toolbar will allow me to quickly choose the fillet command to reduce mouse travel. And here we have the first example of artificial intelligence. I can select the selection helper icon, which will give me some suggestion on where it's most likely that I want to create other fillets. So I will confirm, but also I can still select additional edges to my fillet command. So it will be 5 millimeters, and I will confirm the the selection. Then I'm going to mirror this model because the design intent is to have a component that is always centered between the two brackets, so I can see my nice preview, and then I can confirm. Then I need to add some more geometry. I will create a new sketch. But rather than creating a new sketch or creating geometry from scratch, we have the ability to reuse existing geometry thanks to the insert sketch command. So this command will allow you to search for a component where this sketch geometry was present. So in this case, I remember that the sketch geometry I need is present in a component named skeleton key lock. So I simply type the name of this component. I can select this component, and then the insert sketch command from a drop-down menu will allow me to select the sketch that I want. So I will select the skeleton key, and then I will insert the sketch. And this will save me a lot of time because this is a geometry that I could reuse from another component. Then I'm going to create a cut. Again, I choose the extruded boss, but this is not a problem. I don't have to cancel. I can switch to a cut feature, but you know, I could even from this command create a thin feature or even a surface. There is a lot of flexibility thanks to the super features. So in this case, I will select the cut extrude command. I will define a through all direction cut, which will completely cut my model. And the last thing that Eric now needs is to apply some material. So he will select the component, and then he will choose from the context menu the apply material command. So Eric, in this case, can choose the 1023 carbon steel. And then we're finished with the part. We can switch to editing the assembly by simply double clicking. So as you see, this is really very quick. And we want to test how robust is this parameterization. In this frame component, there is a layout sketch that defines the distance between the brackets. So we're going to modify this sketch. And here we have 250 dimensions that will drive the distance between the brackets. So I'm going to change this distance from 250 to 270. And the result of this operation after the rebuild is that the distance between the bracket will increase and also the spool will follow up. Next, Eric wants to check on the progress made by Debbie on the controller unit, which is the green PCB you see connected through a cable. Eric double clicks on the power and control assembly, and he gets this message that pop-ups and says that the component is reserved and also mentioned by who is reserved, which is Debbie. This means that he won't be able to make or save any changes, but there's good news. He can send a request to Debbie to unlock the geometry. So he will click on send request, and this will give Debbie designer a notification instantaneously that Eric needs to work on that model, and Eric's work is pretty much done for now. So let's recap what we've seen. You can make parametric part design from anywhere, any device. You have new modeling paradigms like super features and the artificial intelligence. And you know, with the built-in data management, you can collaborate when you are in team, for example, by getting this warning that someone is using your file, and then you can ask to kindly unlock it. The next topic will be the design of the controller with the subdivision modeling. So in this case, we will switch to Debbie Designer, and she will be in charge of designing the controller using sub-D modeling with an app called X-Shape. And she's going to do this at the same time as Eric is working on the assembly. So we're going to switch from Eric, that was working on the assembly, to Debbie working on the subdivisional modeling. So Debbie will see the notification from Eric that is requesting to release the lock. So you can check your 3D Spirit notifications by clicking on the bell icon, and by clicking on notification you can get the opportunity to unlock the model. But at this point Debbie is still working on the assembly, and she's not ready to give it up yet. So she's starting a conversation with Eric through the side panel, informing Eric that she's still working on the model and that she'll message him when she's done. And this is a great way for them to keep in touch with each other during the design process. Eric said that sounds good, and he moved on to something else, which is the Firelead design. And this is a very social interaction. You can like messages, you can reply, and Debbie and Eric can be always on the same page. So Debbie will now start to work. Debbie starts working on Xshape, which is a sub-D modeling app. And the first step is adding a primitive, which is almost like a digital hunk of clay. She's going to add a box shape, and she can resize it in any of those principal directions. She can also change the number of control loops that go around the model. And we usually say that less is more, meaning that you should start with less subdivision to have more control of the shape, and then you can refine later on where more detail is needed. What you see now is the robot, and this is the main tool since it's the main way to manipulate the model. It looks like a triad, so the arrows are used to translate the whole body or just the selected area of the model. Then you can also use the arcs for rotating your selection, and then there are the points at the end of those arrows for scaling. And you can translate, rotate, and scale in all one tool, and that covers a big percentage of what you'd actually want to do with subdivisional modeling. Debbie will align the model, but she needs to have it centered respect to the middle plane. So in this case, after moving the model, if she selects the plane, the In Context toolbar shows a command to center the submodel. The In Context toolbar will show up with different commands based on what you select. Xdesign and Xshape are predicting what will be my next move. Then, after centering the shape, Debbie will select the icon to turn on symmetry, which means that whenever I make a change to one side of a model, that will also happen on the other side. And when you design around internal components like enclosure, it's very nice to get a reference for size and shape with being able to turn on transparency. And we can also scale, and you can do it by simply dragging points. You can also translate the sub-D faces to reduce the overall length, and you can also move the whole body. And we'll also refine the side by using the little arcs to rotate the surfaces of a model. After I get the general size and shape of this model, I want some protrusion on the top of the model for ergonomic reasons. And for this purpose, I can click on the face, and then from the context menu, select the Extrude command. And this command will add a protrusion out of the front face. And another quick way to modify geometry without using the robot is inserting loops. So in this case, I'm selecting an edge, and then after selecting the insert loop command, it's creating a new loop perpendicular to the edge that I selected. And now here's another way we can add more control is the subdivide faces tool. So I selected 5 faces. I will select the subdivide face command, and this way we can refine the shape in the region of those selected face. With sub-D modeling, everything is always curvature continuous, but maybe I don't want everything to be so soft. I want some sharp corners, and that's where the crease edges command will come into play. I'll crease some of the edges, but this command is also very useful when you want to create some hollow regions of a model. I'm basically creating an area that will host the buttons, and I will add more creases to make the model look better. And then I will select some faces and simply push them in to create the hollow region. Also, I don't want those edges to be curvature continuous, so I will select them, and from the context menu I will add another crease. So notice that the same thing that designed the best-in-class SOLIDWORKS UI is involved in designing the UI of these tools of the future. I never touch the toolbar. All the tools are at my fingertips near my mouse. I'm going to make further modifications, and then I'd like to highlight some specific robot settings, because right now the robot will automatically align on my selection, but if I need to move faces only in the XYZ direction, I can change the robot settings. So in this case, I will right click and then I can select the XYZ option, which will allow me to move the faces only in the Z direction. So we often get the question, how precise is subdivision modeling? Well, it's as precise as you want it to be. One help can be numerical input. I can select everything I want, and then instead of pushing and pulling the arrow, I just click on the arrow, and then I can type a numeric input for how much I want it to move. In this case, I'm going to move the faces by 5 millimeters, but you can also type -5 to go in the other direction. That's a way to have a very precise dimension. When you manipulate the faces, the result is based on where the robot is, but in some cases you might need to move the robot to get results you want. Think about the rotation. Indeed, I want to rotate the selected faces about the bottom edge, so I can put the robot there and then rotate the faces about that hinge point. I'm going to select some faces since I want to make sure that they're all flat, and for this purpose I'm going to use the align coincident command from the context toolbar. So after making the face flat, I can activate the cage view to see what the surfaces really look like. But because 3D modeling has its foundation on polygons, which are then smoothed out and become surfaces. And the cage mode will basically show the polygons. The advantage of a cage mode is that in this mode you can make faster modification and you can quickly identify interferences and make adjustments, although there is a specific command that will highlight any self-intersecting faces on your subdivisional model. So you see, you have a lot of flexibility of making some modifications to make the aesthetics of this model much better. So if we had to do these modifications on a parametric model using surfaces, we would have needed a lot more time and maybe face some errors. We finally go back to the surfaces mode to see how the model looks like. And then we can do some further refinement of the model. The model looks very, very good. And the X-Shape includes also a draft analysis tools. What's great about it is that it's dynamic. I can set a draft plane and it will colorize my model with positive and negative draft. I can change my model and watch the colorization dynamically change, and this way I can make some adjustments to make the yellow color disappear. So the faces with no draft have been eliminated. But then I need to make some parametric modifications, and what's great about our browser-based design apps is that they can work together. So once I'm finished with the sub-D model, which I can switch to my parametric modeling design app, which is XDesign. After switching to XDesign, the interface hasn't absolutely changed. What's different is that it's just the set of commands, which in this case is features to create parametric functions instead of free-form modeling. In this case, I will create a true-all cut for the button. And notice I didn't even need to create the sketch. The face was used as a profile. I will hide the button to show how does the whole look like. And then instead of recreating the cut, I will press S to make the shortcut bar appear. And from here, I can select the mirror command and I will mirror the cut from one side to the other of this model. This modeling is almost finished. I need the final touch, which is creating a shell to add a uniform thickness to the model. So in this case, I'm going to define a 1 mm thickness. I will shell the wool model to make it ready for injection molding. I will get my preview, and in order to understand what is the result of this shelling, I can use a convenient section view command to show that actually this model is hollow. So I will select the YZ direction. I will flip the section view. And of course, this is just a concept. More features will be needed to make it moldable. And then I can change the color of the model, so I can choose a yellow color. After changing the color, we can save this component to the 3D Experience platform on the cloud to make it available for everybody. So I click on the save icon. Also, the design apps feature the ability to create some to-do lists. And since I had a task defined for this model, I will drag and drop the model to a task, which was in work state. And since I'm finished, I can move my task to the completed state, so that my peers will know that this work has been done. So we want to close the loop with Eric, so let's get back to the conversation with him. And we will let Eric know that we're done with the controller subassembly we were working on. So Debbie is done. This means that Eric will need to do a refresh, which will reload the latest version of the subassembly from the server to see the changes. So Debbie is done with her work. We will now switch to Eric. So Debbie said to refresh. So let's click the refresh button to refresh that specific subassembly. Eric likes Debbie's work, even the color which matches the sheet metal frame, and responds to Debbie. So let's summarize. With the X-shape, you can conceptualize in seconds and create a very quickly complex model. You have the free form given by subdivisional modeling, but you don't sacrifice precision and control because you have all the tools to yield them. And we've seen that with the immersive communication tools, we can collaborate very efficiently with our peers. So now let's see the next topic, which is the design of the sheet metal roller fair lead. And we will go back to Eric, who will be in charge of designing this sheet metal part. So Eric will use some sheet metal part design techniques. So let's start working on this fair lead frame. We will open another widget, and here we have a subassembly with some layout surfaces. Basically, these surfaces have some dimensions that will define the spacing of those rollers. But this will also drive the fair lead frame. So Eric will start by sketching the base plate. And in this sketch, he will reuse as much existing geometry as possible, for example, by using convert entities or by creating some geometry that will snap to existing entities. In these design apps, dimension is very easy. You simply need to click on an entity, the dimension will show, and then you will need to simply change it. Let's press S to bring up the trim tool. So Eric will trim some entities to complete the contours. And after doing that, we will create a wall. The first thing we need to do is to define the sheet metal parameters like thickness, bend radius, K factor, and also the relief is important, so it's going to choose the round relief options. These parameters can be changed later at any time and they will impact this wall feature. We will select the profile that will be part of this wall feature, and then we will confirm. Eric can click on one edge, and the in-context toolbar will show us the commands that are only relevant to the sheet metal, and one of them is wall on edge. So with just one click, we can access the command and adjust various parameters like the material height or the height of this flange. And we can make the height 65 millimeters. We'll do exactly the same thing again to make a new wall for the top part of the fair lid. So we'll make another sketch, again referencing some existing geometry. We will fast forward through the sketch since you already seen how easy it is. When finishing, sketch will transition from blue to black, indicating that it's fully defined. So we just need to define a last dimension, and this wall will be done. So we will exit the sketch, and the S key is dynamic. So in this case, we are in the modeling environment, and we only have sheet metal tools relevant to that environment. We will make a new wall from the S key menu, but now we have after creating the wall, you will notice that we have two separate sheet metal bodies. How do we connect them? Well, there is the band feature, will add a band between two walls. So we will use the band to merge the two walls. It's very simple. You just need to click the two bodies, and now they're joined into one with the relief that we've set. There are some sharp corners that need to be filleted, and when you click on one edge or an entity, the in-context menu will predict my next move, which will give me the option to add a fillet. I can use the suggestions from the selection helper again with artificial intelligence. Looks good. I'll accept the suggestion helper recommendation and also grab a couple more to define these fillets. The 10 millimeters radius is okay, and my part is finished. Actually, this is only 1/4 of part, so I will click S key again to get the shortcut bar again near my mouse, and I can mirror everything I did. So from the S key menu, I'll select the mirror command to mirror the entire body, and this will allow me to create half of body. So I will need to do this again. So I will select mirror body, select the mirror face, and now looks good. All I need to do now is to add a material, since it will be very important to choose one that will be strong enough. 1023 carbon steel should work well. I could search for material or just look in these folders for material type. Looks good now. I want to see our flattened version of this sheet metal part, and I can do that directly from the context menu by clicking a face. If I want, I can go back to the folded view in the same way. But now I want to see how this frame responds when I make changes. So I want to edit the sketch at the assembly level that drives the position of the roller. If I don't want to go back in the sketch, I can use the Edit Sketch Dimensions option to save a few clicks, because the dimensions will appear, and I will change the dimension from 120 millimeters to 135 and see what happens. As we see, the geometry updates perfectly as I would have expected. But now it's time to add this component to the fair lid assembly. So I can minimize this widget. I will see the other instance of its design with the entire assembly. I can drag and drop from the design manager right into the other assembly to insert it. I can add a couple of basic mates to position this. We will do this very quickly since you've already seen this process. So the aim is to have this again in a centered position. But now I need a hole in this fair lead frame in order to attach it to the hull winch. So I want to roll back in my design so that I only have to add this hole once. And I can do that in sheet metal. So I will create a new sketch on this face, and rather than sketching the circle, I'm going to find the existing hole in the winch and recycle it with the convert entities command to project the geometry. I'll then use this sketch to punch a hole through the fair lead frame, and then I will confirm the feature. Looks good, and as you notice, this geometry is all driven by other components, and that's great when you need to update it in case because you'll be 100% sure that the holes will be always aligned. Now I will roll forward once again, and we can then visually verify that the hole now propagated to the other side of this frame. So this all looks good, but one of our deliverables for this design is a DXF of a flat pattern so that we can get quotes from the sheet metal manufacturer. In 3D Sheet Metal Creator, the role that includes this app called Sheet Metal, there is an export to DXF tool that we can use. We can save directly to your hard drive, or we can put it to 3D Drive, which is the generic storage app on the 3D Experience platform. So let's use 3D Drive, and we can now see it show up on the right here in the side panel. And we have some options to share it. We can activate an external sharing link to send to the manufacturer, which will be able to look at this file without installing any software. Anyone can click on this link and see the content as long as they have a 3D Experience ID. If they don't have, it takes less than 30 seconds to make it. So what does it look like at the manufacturer point of view? Here is what they will be able to see in the window. They can mark this up, they can download it, print it, and more directly from here. And so Eric is done. Let's recap. So we have a sheet metal design tool that allows to design from any device, which has all the features that will make this part manufacturable, and will also allow you to create the flat patterns to export it to DXF. And thanks to the storage app 3D Drive, we can easily share with your customers and peers the DXF, for example. So we've seen a few browser-based design apps, but there is an ecosystem of apps. You get apps for designing weldments, to create product manufacturing information, to create renderings, presentation, to create molds, and also to do algorithmic generative design. So in the 3D Experience platform, we have apps, but they are organized in roles from a licensing point of view, functional roles. So you could subscribe to the role to do subdivisional modeling if all you need to do is subdivisional modeling. If you want to do only sheet metal, you have the role called 3D Sheet Metal Creator that will allow you to do only sheet metal design. And this is great respect to traditional CAD, because in traditional CAD you buy a software that will do a lot of things, but maybe you're only using 10% of the capabilities. So this roles concept will give you more flexibility. So in summary, the 3D Experience platform will eliminate completely the overhead because you don't install any software if you have browser-based design roles, and you don't even need a server because you have secure cloud data management. You can collaborate very easily with your team members, with customers and suppliers. Your data is always available anywhere and from any device, and you can even design from any device. It's very easy to deploy since you don't install anything, and you get very frequent updates, something like every 2 months. With these apps that are complementary, they work together.